Morning students, today's topic in mathematics is the perimeters and areas of the composite plane figures. So concentrate yourself, this is important topic. Composite figures are formed by joining two or more basic geometrical shapes. So this is actually a figure that is formed by joining two or more figures. So that figure will be called composite figure. So first we are going to revise the formulas for some basic figures. For example, parallelogram. This is a parallelogram in which opposite sides are parallel, but none of the angles are 90 degree. This figure is called parallelogram. The area for the parallelogram is base into height, and the perimeter of the parallelogram is 2 into length plus breadth. So these are the formulas for perimeter and area of the parallelogram. Rhombus. Rhombus is a special figure in which all sides are equal but none of the angle is 90 degree. This is called rhombus. The area for the rhombus is base into height and the perimeter is 4L. Next figure is trapezium. Trapezium is a figure in which one pair of the sides is parallel and the other pair of the sides is non-parallel. The area for the trapezium is 1/2 into sum of the parallel sides multiplied by height. And the perimeter for the trapezium is sum of outer boundaries. The next figure is circle. The formula for the circumference or the perimeter of the circle is pi r square or pi d. The next figure is a rectangle. Rectangle is a four-sided figure in which opposite sides are equal and each angle is of 90 degree. The formula for the area of the rectangle is length multiplied by breadth, and the perimeter formula for the rectangle is 2 into length plus breadth. Square. Square is a figure in which all sides are equal and each angle is of 90 degree. The formula for the square area is L square, and L is the side, and perimeter of the square is 4L. Triangle. The area for the triangle is 1/2 into base into height, but the thing to remember is height is always the perpendicular one, and the perimeter of the triangle is sum of the outer boundaries. Here is a figure. In the diagram, the shape is made up of the trapezium ABFG. So this is trapezium. Rectangle BCEF. So BCEF, this is a rectangle, and a semicircle CDE, and this is a semicircle. So this is a composite figure. This is actually composed of a trapezium, a rectangle, and a semicircle. So the requirement is find the perimeter. Okay, actually the perimeter is the sum of all the outer boundaries. So actually this is 15, this shows this is also 15. So this 40, 15, 15 is given. If this is 22, then the radius of this semicircle will be 11. So if this is 11, from the origin to any point will also be 11. So this is 11. Okay, this total length is given 55. So now we are going to find the length of BC. So BC will be equal to 55 minus 12 minus 11, like this. So this is the length of the BC, that is 32. If BC is 32, this will also be 32. Okay, up to here from all top parts we have the lengths. Now this is the only curved part that is missing. So we will find the circumference, the curved part of the semicircle. That can be found out by putting the formula 2 pi r over 2, where r is 11. So in this way you will find all the values and will add them to find the perimeter of the figure. The second part is the area. The formula for the area of the trapezium is 1 by 2 into sum of parallel sides. Parallel sides are 22 and 40, and into height is 12. So you will find the area of the trapezium separately. Then the area of the rectangle. Rectangle's height dimensions are 22 and 32. So the area for the rectangle is length into breadth. So length is 32 and breadth is 22. So 32 into 22 you will solve it separately. That will be the area of the rectangle. And finally, you will find the area of the semicircle. Semicircle's area will be pi r square divided by 2, where r is 11. You will solve it separately. And finally, you will add all the areas to find the area of the figure. So that will be the answer of the B part. Here is another question. Find the area of the shaded figure. All circular portions are semicircles. Take pi is equal to 3.14. So this is the figure. So look now, we will technically handle this figure. Shift this portion over here and shift this portion over here. So these two portions will be covered. So now if you look carefully, this is a rectangle now, which is having dimensions 13 by 6, because this is the 13 and this is 6. So dimensions of the rectangle are 13 by 6. So if from the full rectangle we subtract these two semicircles, that will be equal to the area of the shaded portion. Okay, further if you look, these are two similar semicircles which are having the radius 3. So it means in total these two semicircles will make one complete circle of radius 3. So look now, if from the area of the rectangle we subtract the area of the circle of radius 3, we will get the answer. And the area of the rectangle dimensions are 13 by 6. So 13 into 6 is the area of the rectangle, minus pi r square is the formula for the circle. Pi's value is 3.14 and radius of the circle is given, that is 3. So put these values into the formula, solve it on the calculator, you will get the answer. The statement of the question is, find the perimeter and area of each of the following figures. All circular parts are semicircles or quadrants. All measurements are given in centimeter. Pi is 3.14. Okay, if this side is total 19, this is 8, this is 7, so 7 plus 8, 15. 19 minus 15 will be equal to 4. So if this is 4, this will also be 4, this will be 4, this will be 4, and this will be 4 as well. So now all these sides are given. The perimeter will be equal to the sum of the outer boundaries. That will be equal to 4 plus 4 plus 8 plus 4 plus 19 plus 4 plus 7 plus 4. So sum of outer boundaries will make the perimeter. Now the second part is find the area. So now draw a hypothetical imaginary dotted line from here. This composite figure will be divided into two parts. That is actually, one is square and second is rectangle. So square's formula is L square and rectangle's formula is length into width. Square is having a side of 4, so 4 square, plus rectangle is 19 by 4. So solve it on the calculator, you will get the answer. That will be in centimeters square. This part is find the perimeter and area. So to find the perimeter, if this is 20, this will be 20 as well. And these are actually parallelograms. So if this is 20, this will be 20 as well. And this is 20, this will be 20 as well. If this is 40, this is 40 as well. So find the perimeter of the figure. So 1, 2, 3, 4, 4 times are 20. Plus 2 times of 40. Solve it on the calculator, you will get the answer that will be in centimeters. Okay, to find the area of the full figure, there are actually two similar uh, parallelograms. So area will be equal to 2 times of base into perpendicular height. So perpendicular height will be half of this one, that will be equal to 12.5. Solve it on the calculator, you will get the answer. Unit will be centimeter squares. Okay, requirement is find the perimeter and area of these figures. These are composite figures. So if this is 10.6, this will also be 10.6. And 1, 2, 3 sides are given. Only this curved portion of the semicircle is the requirement. Radius of the semicircle will be 7. So 10.6, the perimeter will be 2 times of the 10.6 plus 21. These 3 sides are covered. So this semicircle's perimeter curved surface is required. So 2 pi r divided by 2. Solve it on the calculator, you will get the answer. Now area is the requirement. This is a trapezium and this is a semicircle. So pi r square, r of the circle is 7, so 7 square over 2, because that is a semicircle, and here is a trapezium, 1 by 2 into height. So if this is 7, this is total 17, so height of the trapezium will be 7 into sum of parallel sides, so 14 plus 21. Solve it on the calculator, you will get the answer. Here is another part. If this is total 4.5, this is 2.1, this will be 2.1 as well, so this will be 2.4. So this side and this sides are given. Only the curved part of the quadrant is missing, whose radius is this one. So perimeter will be equal to 2.4 plus 2.5 plus 5.8 plus 2 pi r, r is 2.1 divided by 4. So solve it on the calculator, you will get the perimeter. Area is, okay, here is a trapezium in full, and this quadrant should be subtracted to get the required answer. So area of the trapezium is 1 by 2 into height is this one, 2.1, into sum of parallel sides. So parallel side is 4.5 and 5.8. This is the area of the full figure, from where this quadrant should be subtracted. Pi r square, 2.1 square over 4. Solve it on the calculator, you will get the answer. In these parts, area of the shaded portion is requirement. So from here, from the area of the semicircle, area of the trapezium should be subtracted. So I'm giving you the values. You will put here r of the circle. So this is the total diameter. So 14 will be the radius. You will put 14 in place of r. So this portion will be solved. Height of the trapezium is this one, because this and this are parallel sides. So 9 plus 9 and 28 will be put in the bracket, sum of the sides, and this is the height. So 6 will be h. So solve it and solve it on the calculator, you will get the answer of the required portion. In this part, this is actually a square, full figure. So the required shaded part is, this is a full square from which 1, 2, 3, 4 quadrants should be subtracted. So L's value is 7 plus 7, 14. So 14 will be placed in place of L. Pi's value is 22 by 7 and R's value of the circle is 7. So you will put the values from the figure into the equation and you will get the answer. Okay, here is a question. The shaded parts area is the requirement. This is 33 and the diameter of the semicircle is 21. So half of the 21 will be 10.5. So this will be the perpendicular height of the parallelogram. So from the required area is equal to base into perpendicular height. From this, semicircle should be subtracted by r square. R is 10.5 divided by 2. Solve it on the calculator, you will get the answer. Okay, in this part, if we draw a line from here to here, this half portion will be covered here and half portion will be covered here. So this will make half of the square. So the required shaded part will be equal to half of the square, and square's length is 28. So 28 square. Solve it on the calculator, you will get the answer. Another question is here. The figure below shows a pond surrounded by jogging track measuring 2 meters wide. So this dark portion is a jogging track, and in between there is a pond. Requirement is find the perimeter of the pond. Okay, the perimeter of the pond will be equal to this is 20 and this is 8. So this is a rectangle. So 2 into 20 plus 8. This is the perimeter of the rectangle, and 2 semicircles are also there. That will make 1 complete circle. So 2 pi, radius will be 4. So solve it on the calculator, you will get the answer of the perimeter of the pond. Okay. Now the requirement is the area of the pond. In B part, the area of the pond is the requirement. So this is a rectangle and 2 semicircles. So length multiplied by width. So 20 into 8. This is rectangle's area. And 2 semicircles make 1 complete circle. So pi r square. And r is 4. Solve it on the calculator, you will get the answer of the B part. That will be the area of the pond. And C part's requirement is the area of the jogging track. Okay, area. So this is a bigger rectangle now. So the length is the same, that is 20. But width is greater, that is 8 plus 2, 10 plus 2, 12. So 12 is the width now, but length is same, that is 20. So this is the bigger rectangle plus bigger 2 circles, 2 semicircles, that will make 1 bigger circle, pi, and r is 10. So 10 square. This is the area of the bigger portion, full portion. From it, subtract the answer of B's part. B's answer subtract. That will give you the area of the jogging track. Here is a question. In the diagram, AFE is a semicircle, center G. Okay. AC 18, BD 37. A is parallel to BD. Okay. And the total area of the shaded part is 63. So this is the key point. Calculate the length of AE. AE is the requirement. So suppose if we let the radius r, this will be r, this will be r as well, and this will be r as well. So the shaded portion is the key point. So semicircle minus triangle. So semicircle is pi, Radius is small r, so that will be equal to pi r square divided by 2 minus triangle 1 by 2 into base into height. Base is 2r into height is also r. So this is actually shaded portion, that should be equal to 63. So solve it now. Take okay, from here r square will be taken as common. Remainder will be 1 by 2 pi minus 1 by, so this will be cancelled, so 1 will remain here, is equal to 63 as well, will remain as it is. Solve it on the calculator, you will get the value of r. Okay, the length of AE is actually 2 times of the r, so AE is equal to 2 times of the r. Put the value of r from here to here, that will be the answer of A part. B part is calculate the area of the trapezium. So this side and this side is, now we have parallel sides and this is the perpendicular height. So very simple, B part is 1 by 2 into perpendicular height into sum of parallel sides, so that will be the answer. Here is a very important question. A bicycle wheel has a radius of this. Calculate the number of the revolution which the wheel would make in traveling a distance of 1.98 kilometer. Okay, the number of the revolutions. So A part is number of revolutions will be equal to, this is the total distance, that is 1.98 kilometers. So we will convert it into centimeters. So in 1 kilometer there are 1000 meters, and further in 1 meter there are 100 centimeters. So this is in centimeters now. Divided by the circumference of one complete circle. So this is the radius. So 2 pi into radius is 21. So total distance divided by the circumference of one complete circle, that will give you the answer. Solve it on the calculator. Okay, B part is a motorcycle wheel has a diameter of this. Find the number of the complete revolutions made by the wheel per minute when the motorcycle is traveling at this. Okay, again we will find the circumference of one complete circle, that is 2 pi r. Okay, r will be 28. This is the distance traveled by one complete circle. So from here we can see now the distance traveled by the wheel at the speed of this. So in 1 hour, the thing is actually covering 48 kilometer. So convert it into centimeters. In 1 kilometer there are 1000 meters. Further in 1 meter there are 100 centimeters. So actually this is the distance traveling in 1 hour. In 1 hour there are actually 60 minutes. And the distance covered in 1 minute will be equal to 48 and 5 zeros. Okay, centimeters. So actually now we want to find the complete revolutions made by the wheel per minute. So divide number of revolutions will be equal to 48 000 over this 2 pi into 28. Solve it on the calculator, you will get the answer. Okay, C part. An old bicycle has a large front wheel and a small rear wheel. Okay, this is the figure. The radii of the front and rear wheel are 63 and 21 centimeter respectively. Calculate the number of the revolutions made by the rear wheel for each revolution of the front wheel. So this is very simple. Divide okay, circumference of the bigger wheel should be in numerator, and in denominator put the circumference of the smaller wheel. Solve it on the calculator, you will get the answer.